What's going on, everybody? Austin here, back again from Cyborg Security with another Threat Hunt Deep Dives video. Hey, I just want to thank everyone so much who have been watching our videos and have given us really great feedback. It's been really awesome, so thank you so much. And in the last episode, we talked all about that SolarWinds supply chain compromise and the Sunburst backdoor. We went really in depth on it. You don't want to miss that video. I'm going to put an annotation for it somewhere on the screen so you can click on that if you haven't seen it already and watch it. You don't want to miss it. It was very cool. And I don't know about you, but that whole SolarWinds snafu just really rocked my December, and I think a lot of other people, it rocked their December in the security community. So I thought that we'd do something very chill today, and so I pulled out of the closet an Apache Struts remote code execution vulnerability. This is something that happened at the later in the year last year. And man, poor Apache Struts, I think it seems like once or twice a year that one of these pretty critical vulnerabilities is found in their software. So I thought it would be interesting and somewhat low-key to share with you today. And this is CVE-2020-17530. Like always, I'm going to do an overview of this threat, and then I'm going to emulate it on systems of our own, and then I'm going to show you how to hunt for this in your environment so you can make sure that you and your enterprise are protected. And then if we have time, and if you want to stick around towards the end of the video, I'll get into that nitty-gritty portion. We'll take even a deeper look at it, maybe get into some code, things like that. So stick around. It's going to be a fun one. Let's get into it. All right, so to give a quick overview of CVE 2020-17530, this remote code execution vulnerability within Apache Struts. And if you're unfamiliar with Apache Struts, or if you're only somewhat vaguely familiar, it is a web application framework, and it's for Java applications. So a lot of times probably you're on the internet and you are interacting with websites and likely are unaware that you're interacting with an Apache Struts website. It's pretty popular out there. It's been around since the early 2000s, has gained in popularity, might be decreasing a little in popularity these days, but is still quite ubiquitous out on the open web. And this is what makes it such a vulnerable target for a remote code execution vulnerability, because this is going to be a public-facing web application most of the time. And so this vulnerability, it affects Apache Struts version 2.0.0 to 2.5.25. And the way that it works is the Apache Struts framework has this thing called the Object Graph Navigational Language, or the OGNL, somewhat of a mouthful. And the way that this works is that there is a forced OGNL evaluation on raw user input and tag attributes that leads to this remote code execution. So a lot of jargon in there, but essentially what this means is that the Apache Struts framework has this sort of language inside of it that it understands and can interpret, and you send this Apache Struts website either a GET or a POST request, and it's going to evaluate this syntax, and we're going to abuse it a little bit, and it's going to double evaluate a term that you're going to send it, and that's how we're going to get remote code execution vulnerability. And I've got a few links open here that I'll kind of go over. Once again, all these links, as always, they'll be down in the description, so if you want to check any of this stuff out. The first one that I have up here, just kind of for the sake of it, is this NIST link. So this is just kind of going over the same thing as we're seeing here. These are the vulnerable Apache Struts versions, and it has some brief information here. Also has a nice link to PacketStorm. PacketStorm is always great if you're interested in getting more in depth with threat hunting or looking at exploits and shellcode and all that sort of cool stuff. Has a great explanation of the threat up here. And then down below, and this is very cool, a Metasploit module is included now with Metasploit for this remote code execution vulnerability. So if you want to try that out, you can use the Metasploit module. Or if you'd rather use a Python script, this is directly from Cyborg Security. Once again, link will be down in the description. github.com/cybersecurity/CVE 2020-17530. I went ahead and coded up a Python script that does this forced OGNL evaluation. You can use it against a website here for testing this exploit out, which we'll do right after this. And you can see that I've got some information that we're going to get into further. And I briefly want to talk about the OGNL and furthermore on how this exploit works. So what this OGNL is an expression language for Java. So once again, Apache Struts, they are these Java web applications, and it extends the Java Servlet API. And this is always just kind of a hotbed for bugs within applications, is when you sort of have a language within a language, or if your language is interpreting things. We see this quite often, that this is just a hotspot for finding vulnerabilities. And that's what happened here, because how this works is that Apache Struts can be forced to do a double evaluation on certain attributes, which leads this to the RCE. You might have seen it briefly here when I popped open this Python script. You can see that I've got this build payload function. This is that OGNL syntax. It's a quite long payload. You can see that within here, one of these sort of arguments that we give this OGNL syntax is a arglist add. And this is where I'm putting a command within my Python script here. This is what gets double evaluated by the OGNL syntax incorrectly within Apache Struts, those vulnerable versions. And that's how we're going to get remote code execution, remote command execution on this host, and be able to run whatever command that we want on this system. Keep in mind that when we talk about how this vulnerability works, that it is application and configuration dependent. Meaning that not every Apache Struts of this version that we were looking at previously, it doesn't come out of the box vulnerable. It depends on how you're deploying your application, and also the way that you're going to exploit it is going to be dependent on how the application is configured in the real world. So that's a nicety to this. If you're deploying Apache Struts and you have one of those vulnerable versions, it's not vulnerable out of the box. It all depends on how it's configured. So now what I'm going to go ahead and do is I'm going to use this Python script that I've developed. Once again, you can find it in our GitHub repo. I'm going to show you how we're going to stand up a vulnerable version of Apache Struts using a Docker container, and then I'm going to show you how to exploit it. Let's do it. All right, let's go ahead and perform this exploit. Let's get into the fun stuff. And sorry if I seem like I'm shivering a little bit. I just dipped outside for a minute, and I'm here in Texas. I don't know about you guys, but it's pretty cold out there for me. I think it's like 30 degrees or something. So sorry if I'm shivering. So I've got two shells open here. On the left, I've got Debian VM. This is where we're going to run Docker, and we're going to run a vulnerable Docker container that has a version of Apache Struts that we can perform this remote code execution on. And on the right, I've got a shell for my local box. That's where we're going to perform the exploit remotely to demo this. So on the shell here on the left, we want to make sure that we have Docker running. So if I use systemd's system control and I do a status on Docker, we can see that it's active and running. If you don't already have Docker, you can go ahead and Google that and set up Docker on your system as you need. And it's cross-platform. You don't need to be running on Linux to run these containers, obviously. So I'll go ahead and do a Docker pull, and I'll go ahead and copy this container that we want. So this is Vulhub / struts 2:2.5.25. This is found on Docker Hub out there, so you can easily do a Docker pull command. And Vulhub's a really awesome open source project. A whole bunch of different contributors, and they make these vulnerable VMs that you can try out exploits on. So it's a really cool service that they got going there. So you can see that it pulls down pretty quickly here. And the next thing that we want to do is actually start that Docker container up. So I'm going to do a Docker run, and I'm going to do a -d. This is going to background it and also daemonize this container. And then I'm going to do a -p, and what this is going to do is expose the port. So locally in the container, it's going to be listening on port 8080, but we want to perform this exploit remotely, so I want to expose that port. And I'll go ahead and put that Vulhub struts container there. So you can see it starts up, and it backgrounded itself. So if I do a Docker ps, you can see that this container is up and running. So now that we have that rolling here, and if I want to, I can do a netstat, and I can just make sure that it's listening here. So you can see that it's listening on port 80, so we're good to go. And the next thing I want to do here is go ahead and get that exploit script that I mentioned earlier. It's within our GitHub repo, so github.com/Cyborg Security CVE-2020-17530. So go ahead and do a git clone on that. And if I cd into this repo now, you can see we've got a Python script, and we also have this requirements.txt. So this is going to require Python 3 to run. I believe it's going to require over Python 3.6. So make sure that you have a Python version that's going to allow that. So you can see I'm using latest, which is Python 3.9.1. And the requirements that are going to be needed is requests to perform the HTTP request needed. and Beautiful Soup 4 that's going to do some of the post-processing on the HTML data that we're going to get back when we do our remote code execution vulnerability. So if you need to install these requirements, you can just do a pip command. It might be just pip on your system, or if you want to specify pip3, that's for Python 3, and you can do an install-r on the requirements.txt and get all of the requirements that you need. So if you want to see the help options for this Python script, you can just run Python with the script name and do a -- help, and you can see it's just like a standard command line utility. It's going to tell you exactly how to run it here. So what we're going to need, whoops, I want those help arguments. What we're going to need here is the IP address from our target machine. So I'll just do an IP adder, and this is a box of virtual machine on my local network. So here's this IP address. And the way that we'll run this is we'll do the script here, and then I'm going to follow along with the help options. So the tac-c is for a command. So this is the command that you ultimately want to run on the system. So I'm just going to do the ID command. This will show us the privilege level that we're running on that system that we're going to run the remote code execution vulnerability on, and the -n. And this is where it gets into that application and configuration specific that I was talking about previously, that this vulnerability doesn't work out of the box on Apache Struts. So in this case, the form data name that we want to target is also ID. It doesn't have anything to do with the Linux command that we're going to run. It just happens to be that they're the same name. So if you are running this on a different application, you have to figure out what that vulnerable parameter is that you're going to use against this OGNL syntax. So use that -n, and then tac-p, that was that port 8080 that I exposed on our virtual machine there. And then I'll do the -- target, and this is where we want this IP address. Whoops. So I'll go ahead and throw this IP in here, and I'll go ahead and press enter. And you can see immediately, it's very cool, this remote code execution vulnerability, this fired off, and this is the output of the ID command. So if I run ID here, you can see obviously it executed within the container, but this is running that ID command on that system doing remote code execution vulnerability. So now if I change this -c, we could do something like an ls, or we could do who knows, who am I? And you can see that we're running remote commands on this system using this forced OGNL double evaluation. Some very interesting and cool stuff here. So now that we've performed the exploit, I'm going to show you some ways that we can defend against this. So the first thing I'm going to show is how this exploit looks across the wire. So I'm using Wireshark here, and a lot of times people might be threat hunting using similar tools with raw network data, perhaps something like Moloch, Wireshark like I'm using. Perhaps you have your HTTP data and more going into an Elasticsearch instance, something like that. So here in Wireshark, you can see that I have everything going to this port 8080. You can see that I've got some HTTP packets. And specifically what happened when we did the exploit is it did a post request to the server using that vulnerable parameter, which was ID. And that's how I did this forced OGNL syntax. So if we want to get a good view on this, what you can do in Wireshark here is you can right click and you can do go down to follow, and you can do follow TCP stream. So this is always something great to do. And what you can do here is you can actually see directly what the HTTP protocol syntax looks like within the actual body. So you can see it's doing a post request, and as we can see, we didn't change the user agent string, so it's got that Python request user agent string. And down here, you can see the content type is this multi-part form data, and within the multi-part form data is this giant blob of payload. This is that OGNL syntax that we have been talking about this entire video. And you can see within here, if we kind of go to the end, this is this payload that was within our Python script, and you can see that there's this arglist.add ID. And at the very end here, you can see that it's doing an execute exec arglist. So this actually does that double evaluation, goes back to the arglist, and then executes it. So this is how we're getting remote code execution of the vulnerability. This is how that ID command was able to run. So if you are looking at raw network data and you're trying to hunt for this in your environment, you have this HTTP data. One thing that you might want to do is actually search for some of these specific strings that are within this OGNL syntax body. One thing that I think that you might want to search for, and this might also catch other things that are of interest within your raw network data, is anytime that you see execute.exec within a body of HTTP data, we probably want to investigate that further and check out what's going on. So within Wireshark, very easy search to do here is you can do HTTP and you can do contains, and then we can send it that string, execute.execv. Now here I've only got a dozen packets, not too much here. But if I do search on this, we can see immediately that we get these two HTTP packets of interest here. So you can use this search within Wireshark, or perhaps you can adapt it to whatever sort of raw network data tool that you're using, and then you can find the exact packets that you're looking for, and then you can drill down further, look at the actual communication that's going back and forth with HTTP. Perhaps it is something benign, but I think if you're ever going to see something like execute.exec within your data, you're going to want to investigate that. And you can see here it doing this, very funky OGNL syntax, and it actually executing commands on the system. And then what you can see, if you scroll down here, is actually the return body. So you did this post request, and then when it returned, the scary part is that we can see right here in the return request. Normally, you would see like some sort of href, which you see later, but here also within this HTML tag, there's also the ID output, which was that vulnerable parameter, and it's returning with the actual command ID showing this. So, if you're ever seeing something like this in your data, obviously it's a little bit frightening, and you're going to want to follow up, do some triage, and figure out what's going on here. So this is at least how to hunt and how to track some of this stuff down using some of these raw network data type tools. Another tool that you can use to detect these sort of things within your environment is something like Snort or Suricata. These are IDS, intrusion detection systems. Here I'm going to be looking at a Suricata rule. So I went ahead and I already pasted it down below so you can see it larger. This comes from PerchLabs. Once again, I'll throw a link down in the description, but thanks a lot, PerchLabs. They have put some open source Suricata rules out here in the ether on GitHub. Pretty awesome that they're doing this, all open source. And so you can see, if you come in here to Suricata webserver.rules, that they've got a bunch of listed Suricata rules, and this very first one happens to be a detection for the possible Apache Struts 2 forced OGNL eval RCE inbound, and it's that same exact CVE, the one we've been talking about in this video. So you can see this rule. The only thing that I'm going to do to modify it is I'm going to remove this external net and home net and just change those to any. And so you can come in here and you can actually operationalize this rule. And if we want to, we can test it out. I've got a CentOS machine set up here with Suricata, and I'm going to run Suricata inline. But if you want to, use this rule in production, you're going to want to take this rule. I've got it right here. Take this and actually put it inside one of your rules files in etc Suricata rules, and then make sure you specify that rules file, of course, in your suricata.yaml configuration file. But in order to run this, all we're going to do is I'm going to use Suricata. I'm going to do a -R for reading in the PCAP, and then I'm going to do a -K and none. And so if I run this here, and then what you'll see is it pumps out a whole bunch of different files. And normally what you're going to be doing is the eve.json file, which is going to contain a lot of the alerts and different metadata that's going to happen from your alerts. This normally you're going to pump into something like Elasticsearch or into Splunk or into your SIM. But for right now, I'm just going to cat the file so you can kind of see what's happening here. And you can see that it's picking up this forced OGNL eval RCE inbound because I ran it on that PCAP file up here that we've got on this box. This is the same exact traffic that we were seeing earlier that I was demonstrating inside Wireshark. And this is a way that you can actually put this into operation, make sure that you detect this RCE. And you can see that it also has a lot of pretty cool metadata that's going to pump out, so you can get more information right in the alert about the different actors that may be abusing this on your systems. And so you can see it even has things like the user agent string. We were running this from a Python command line tool using requests. So you can see the exact user agent string. And so you can kind of get some information about, the tooling that actors might be using. And there's a whole bunch more cool information in this eve.json file. So yeah, go ahead and I would definitely recommend checking out this Suricata rule from PerchLabs. I'll have the link down in the description, so you can go ahead and operationalize this and make sure that you're protected from the CVE. Thank you all so much for watching our video. Hope you all learned something about remote code execution vulnerabilities, Apache Struts, Suricata, Wireshark, and more. We got some really cool videos planned for the future, and I will see you guys all in those future videos. So once again, thanks so much for watching.